Hello there, and welcome to the Black Hole Files, where cosmic dread takes a deep breath, and even the most terrifying truths gently drift into dreams. Tonight, we're turning our gaze to the stars, not for comfort, but for caution. Because out there, far beyond our cozy blue planet, lurk forces so powerful, so ancient, and so unpredictable. They could unmake everything we know in the blink of a celestial eye. But don't worry. You're safe here. Maybe curled up in bed. Maybe letting your mind wander as the world grows quiet. And before we peer into the void together, tell me, where are you listening from tonight? And what time is it in your little corner of this pale blue dot? It's fitting, isn't it? A video about time and space. And here we are, scattered across both, arriving at this very moment together. If you find this journey thought-provoking, or just the right mix of wonder and stillness to end your day, I'd be so grateful if you'd give the video a like, maybe even subscribe. It helps others discover this little patch of peaceful curiosity in a sometimes chaotic universe. So settle in. Let your thoughts slow. And don't worry if the cosmos feels a bit too big to hold all at once. We'll explore it gently. Because somewhere between solar flares and gamma-ray bursts, between quiet black holes and ancient stars, lies the strange, silent truth. Space doesn't care if we're ready. But tonight, we'll face it softly, together. Let's begin. Every disturbing cosmic event humanity isn't ready for it started like any other winter morning in Chelyabinsk, Russia. The sky was serene, offering no hint of the cosmic chaos racing toward it. Then, out of nowhere, it arrived. A 20-meter asteroid streaks toward Earth at 60 times the speed of sound. In an instant, a force equal to 30 Hiroshima bombs was released, injuring over 1,500 people and damaging 7,200 buildings across 6 cities. The universe is teeming with ticking time bombs, cosmic events so disturbing it could wipe humanity out in an instant. But what happens when the next cosmic catastrophe strikes, and we realize too late that we weren't ready to face it? Asteroid impact. Despite all our gadgets and brain power, if a massive asteroid decided to surprise us, we'd be about as prepared as a goldfish facing a tsunami. And it's not a question of if, it's a question of when. You see, asteroids are the cosmic leftovers from the formation of our solar system. Think of them as the debris from the celestial construction site 4.5 billion years ago. Most of them reside peacefully in the asteroid belt between Mars and Jupiter. But every so often, one decides to go rogue. And when that happens, the results are catastrophic. Take the asteroid that wiped out the dinosaurs 66 million years ago. That chunk of space rock was about 6 miles wide, roughly the size of Mount Everest. When it slammed into Earth, it unleashed energy equivalent to 10 billion Hiroshima bombs. The impact created tsunamis, wildfires, and a choking dust cloud that blocked the sun for years. The dinosaurs didn't just get unlucky, they got obliterated. Now imagine something similar happening today. We're talking about global devastation. Entire cities reduced to rubble. Climate systems thrown into chaos. Food chains collapsing. Unlike the dinosaurs, we'd know it was coming. The question is, could we do anything about it? You might take comfort in the fact that we have asteroid detection systems. NASA's Planetary Defense Coordination Office monitors near-Earth objects to identify potential threats. Sounds reassuring, doesn't it? Well, these systems aren't foolproof. For starters, we've only mapped about 40% of the asteroids that could pose a threat to Earth. The rest? They're out there, lurking in the cosmic shadows, waiting for their moment to strike. And let's not forget the small but deadly ones. An asteroid just 500 feet wide could wipe out a major city, and many of these smaller ones go completely undetected until they're practically knocking on our door. So, what happens if we spot a killer asteroid heading our way? Surely we'd just send Bruce Willis and a team of drillers to blow it up, right? Not exactly. Hollywood makes asteroid deflection look easy, but in reality, it's a logistical nightmare. One proposed method is the kinetic impactor, which involves slamming a spacecraft into the asteroid to nudge it off course. Sounds simple enough, except for the fact that asteroids can be irregularly shaped, spinning, or made of loosely bound rubble. Hitting one is like trying to throw a dart at a leaf blowing in a hurricane. Another idea is the gravity tractor, where a spacecraft uses its gravitational pull to subtly alter the asteroid's trajectory. While promising, this method requires years of preparation and assumes we'd detect the asteroid far enough in advance. Then there's the nuclear option, blasting the asteroid with a nuclear bomb. It's dramatic, sure, but also incredibly risky. Blow it up the wrong way, and you could end up with multiple fragments still hurtling toward Earth, each carrying enough energy to cause widespread destruction. Even if we had the perfect deflection plan, implementing it would be a race against time. Let's say we discover a massive asteroid that will collide with Earth in 6 months. That's barely enough time to build, test, and launch a spacecraft. And if the asteroid is closer, forget about it. We'd be sitting ducks. Worse still, international cooperation would be essential. Imagine trying to get every major world power to agree on a course of action while the panic spreads like wildfire. Who gets to decide what measures to take? What if the asteroid's impact zone is projected to hit one country but not others? The geopolitical drama could be as catastrophic as the asteroid itself. Let's entertain the grim scenario that we fail to stop the asteroid. What happens next? The immediate impact would vaporize everything within hundreds of miles. Shock waves would flatten cities. Tsunamis would engulf coastlines. And then there's the long-term fallout. Dust and debris kicked up by the impact would block sunlight for years, triggering a phenomenon known as impact winter. Crops would fail. Temperatures would plummet. Starvation would become the new global pandemic. Humanity's survival would hang by a thread, and the world as we know it would be gone. History is full of near misses that remind us of our cosmic vulnerability. Take June 30th, 1908, for example. In the early hours over a remote Siberian forest, the sky suddenly lit up brighter than the sun. Moments later, a colossal explosion, equivalent to 15 megatons of TNT, flattened over 80 million trees across 800 square miles. To put that in perspective, that's an area roughly the size of metropolitan Tokyo, leveled in an instant. Scientists believe this catastrophe was caused by an asteroid or comet fragment about 160 to 200 feet in diameter, which exploded mid-air before it even touched the ground. While the region was sparsely populated, imagine if Tunguska had struck over London, New York, or Mumbai today. The human toll would have been catastrophic, with millions dead and infrastructure obliterated. Then there's the Chicxulub impact, arguably the most infamous asteroid event in Earth's history. Around 66 million years ago, a 6-mile-wide asteroid struck the Yucatan Peninsula in modern-day Mexico. It hit with the force of 100 trillion tons of TNT, carving out the 93-mile-wide Chicxulub crater we can still study today. The immediate effects were apocalyptic: mega tsunamis hundreds of feet high, wildfires raging across continents, and molten rock raining down like a fiery hailstorm. But the long-term effects were even worse. The impact ejected so much debris into the atmosphere that it blocked sunlight for years, leading to a global impact winter. Temperatures plummeted, plants couldn't photosynthesize, and entire ecosystems collapsed. This single event wiped out approximately 75% of all life on Earth, including the dinosaurs. What's unnerving is that the asteroid wasn't particularly unique in size or speed. The Chicxulub event was catastrophic because it hit Earth at the wrong place and time. Scientists estimate similar-sized asteroids pass near our planet every few million years. But asteroids aren't the only cosmic threats looming over our fragile existence. While a rock from space can obliterate life in a single impact, there's something even more terrifying lurking in the vastness of the universe. An invisible sniper that doesn't need to touch the ground to wreak havoc. Gamma-ray bursts. Gamma-ray bursts, or GRBS for short, are the deadliest explosions in the cosmos, releasing as much energy in a few seconds as our sun will in its entire 10-billion-year lifetime. These bursts occur when massive stars die in spectacular supernovae, or when two neutron stars collide in a violent cosmic merger. The result? An intense beam of radiation, a focused death ray of gamma photons capable of sterilizing entire planets. Scientists describe them as the sniper rifles of space. Unlike supernovae, which blast energy in all directions, gamma-ray bursts shoot their deadly energy in narrow, laser-like beams. And, if Earth is unlucky enough to end up in the crosshairs, game over. So, what happens if a gamma-ray burst targets our planet? First, the beam of radiation strikes our upper atmosphere, shattering molecules and triggering a chain reaction. The ozone layer, our planet's protective shield against harmful UV rays, would be wiped out almost instantly. The burst's high-energy photons would break apart nitrogen and oxygen molecules, forming a toxic soup of nitrogen oxides. These chemicals would rain down onto the surface, poisoning the air and the oceans. The sky would darken, plants would wither, and ecosystems would collapse. And that's just the beginning. Gamma-ray bursts are strong enough to strip away the atmosphere entirely, leaving Earth's surface exposed to the harshness of space. Temperatures would plummet, radiation would spike, and within moments, Earth would become a lifeless rock. You might be thinking, has this ever happened before? Well, scientists believe that a gamma-ray burst may have been responsible for the Ordovician-Silurian extinction event 450 million years ago. This mass extinction wiped out roughly 85% of marine species, and the timeline aligns suspiciously with what we'd expect from a GRB-induced ozone collapse. While we've never directly observed a gamma-ray burst hitting Earth, these events are more common than you might think. Astronomers detect one almost every day somewhere in the universe. Most of them are too far away to harm us, but not all stars play nice. The good news: the odds of a gamma-ray burst hitting Earth are incredibly slim. The bad news? Incredibly slim still isn't zero. Scientists have identified several candidates in our galactic neighborhood that could pose a threat. The most infamous is WR-104, a massive star system, about 8,000 light-years away. WR-104 is a ticking time bomb, and when it explodes, it will unleash a gamma-ray burst. If its rotational axis happens to point directly at us, Well, let's just say we won't have time to worry about paying next month's rent. The terrifying thing about gamma-ray bursts is their sheer inevitability. We can't stop them, deflect them, or even predict them with certainty. Unlike asteroid impacts, which we can track and potentially prevent, a gamma-ray burst is an invisible killer. It travels at the speed of light, giving us zero warning. As if gamma-ray bursts weren't enough to keep us up at night. Some dangers don't travel at the speed of light. They creep, undetected, through the galaxy. Enter rogue black holes, the wandering predators of the cosmos. Rogue black holes. Black holes are terrifying enough on their own, massive voids in space with gravity so strong that not even light can escape. These monsters are born when massive stars die, collapsing under their own gravity to form singularities. Most black holes are relatively predictable, staying in their galaxies like obedient pets. They gobble up nearby matter but are generally stationary. Then there are rogue black holes. These are the black holes that escaped their home galaxies, cut loose by violent gravitational forces, like cosmic delinquents with no rules to follow. Scientists believe there are over 100 million black holes in the Milky Way alone, and while most stay in one place, a few roam free. Unlike stars, which emit light, and planets, which reflect it, rogue black holes are practically invisible. They are detectable only through the destruction they leave behind. These wandering voids move through space, swallowing anything that comes too close. No warning, no sound, just pure annihilation. Normal black holes, terrifying as they are, have at least one redeeming quality. They stay put. Rogue black holes, however, are untethered, wandering through space at speeds of up to thousands of kilometers per second. Their stealth makes them particularly horrifying. They don't emit light, radio waves, or any other form of detectable energy. Even if one were heading toward Earth right now, it would likely be invisible until it started to disrupt the orbits of planets or swallowed something significant, like a star. Here's another disturbing fact. Rogue black holes don't just destroy, they warp. Their gravitational pull is so intense that they can distort space-time itself. Nearby objects are stretched and twisted in a phenomenon called gravitational lensing. In practical terms, a rogue black hole doesn't just pass through a star system, it reshapes it. Now, let's raise the stakes. What if a rogue black hole decided to wander into our solar system? First, it wouldn't announce its arrival with fireworks or flashy visuals. It would be subtle, at least at first. The outer planets, like Neptune and Uranus, might start to wobble. Their orbits would shift slightly, as if something invisible were tugging on them. Astronomers would notice the anomalies and sound the alarm, but by the time we pinpointed the cause, it could already be too late. As the rogue black hole moved closer, its gravity would begin to disrupt the asteroid belt, flinging space debris toward the inner planets. Earth would become a sitting duck, bombarded by waves of meteors and comets. And if the black hole ventured even closer, that's when the real horror begins. Earth's orbit would be thrown into chaos, possibly sending us hurtling into the sun or out into the freezing void of space. But the worst-case scenario is a direct encounter with the black hole itself. The black hole's immense gravity would stretch and compress Earth in a process called spaghettification. It's a literal shredding of matter, as the planet would be pulled into a thin stream of particles. Cities, oceans, mountains, everything would be reduced to atomic rubble, spiraling into oblivion. You might be thinking, has this ever come close to happening? Thankfully, no rogue black hole has wandered near enough to Earth to pose an immediate threat. But we've had some unsettling near misses. In 2022, astronomers identified a rogue black hole about 5,000 light-years away in the Carina-Sagittarius spiral arm of our galaxy. It was detected using a technique called gravitational microlensing, where the black hole bent the light of a distant star, briefly magnifying it. This phenomenon gave us a fleeting glimpse of the silent killer before it disappeared back into the void. Then there's Gaia BH1, a rogue black hole located just 1,560 light-years away. While it's not heading directly toward us, its proximity is a shocking indicator that these celestial assassins are out there. The Milky Way is a crowded place, and rogue black holes are the cosmic equivalent of drunk drivers. Here's the frustrating part. Rogue black holes are nearly impossible to detect. They don't emit light, and they're too small to block out significant portions of starlight. Essentially, they're the ultimate stealth weapon. The only reliable way to find a rogue black hole is by observing its interactions with other objects. If it passes near a star, for example, the star's light might warp due to gravitational lensing. But these events are rare and unpredictable. Our telescopes would need to be in the right place at the right time, scanning billions of stars for a faint, temporary anomaly. Future technologies could improve our odds. Gravitational wave detectors like LIGO and the upcoming Einstein telescope might help us identify the subtle ripples in space-time caused by rogue black holes. But for now, our ability to detect them is woefully inadequate. Let's imagine the unthinkable. We spot a rogue black hole heading toward the solar system. What could we do? The harsh reality is not much. Unlike asteroids, which we can potentially deflect, a black hole is indestructible. It's not a solid object. It's a warped region of space-time. Firing nukes at it would be like throwing pebbles into a hurricane. Our only option would be to prepare for the worst. Governments might try to evacuate Earth, but where would we go? The Moon? Mars? Neither would survive a direct encounter with a black hole. Humanity's best hope would be to leave the solar system entirely, a feat that's currently beyond our technological capabilities. Just as we grapple with the terrifying thought of an unstoppable force tearing through the solar system, another silent predator lurks much closer to home. A different kind of celestial havoc that strikes without warning, leaving humanity just as defenseless. Solar superflares. It's a seemingly ordinary day. People are glued to their phones, airplanes crisscross the skies, and stock markets hum with the rhythm of digital transactions. But then, without warning, the world goes dark. Smartphones stop responding. Planes lose navigation. Power plants shut down. And satellites are suddenly nothing more than space junk. The cause? A cosmic assassin, a solar superflare, another catastrophic event we're woefully unprepared for. You see, a solar superflare is a massive eruption of magnetic energy from the sun's surface. Think of it as the sun throwing a tantrum, only this tantrum packs the power of billions of nuclear bombs exploding simultaneously. Regular solar flares already cause disruptions, like the 1989 blackout in Quebec. But a superflare? That's an entirely different beast. It's thousands of times stronger and could send a massive blast of high-energy particles hurtling toward Earth. These charged particles ride the solar wind, slamming into our planet's magnetic field and wreaking havoc on everything electrical. While the sun's magnetic storms are relatively rare, superflares occur on stars similar to our sun. The terrifying part? Scientists believe our sun is capable of this cosmic fury. Before you start building a bunker, let's talk probability. Solar superflares are thought to occur roughly once every few thousand years, but the timing is unpredictable. Historical evidence suggests a massive event, known as the Carrington event, hit Earth in 1859. Back then, telegraph systems, the 19th century's cutting-edge tech, caught fire. Today, the consequences would be exponentially worse. A study in Nature Communications found that the sun unleashes superflares far more frequently than we'd like to believe. In fact, the sun's magnetic activity is showing patterns disturbingly close to stars that have unleashed superflares. Now, imagine the moment a solar superflare hits Earth, the first casualty, our electrical grid. High-energy particles would overload transformers, causing them to burst into flames. Entire countries would lose power within minutes. Replacing these transformers isn't a quick fix either. Manufacturing and installation could take months or even years. No power means no running water in cities, no functioning hospitals, and no refrigeration. Food supply chains would collapse. Suddenly, that fancy fridge stocked with organic kale means nothing when you can't keep it cool. Satellites wouldn't stand a chance. GPS? Gone. Satellite internet? Say goodbye. Weather forecasting? Back to guessing with your grandma's arthritis. In 2022, a relatively small solar storm knocked out 40 Starlink satellites, causing them to burn up in the atmosphere. A superflare would multiply that destruction 1,000-fold. It's not just about losing YouTube and Netflix. Governments, militaries, and industries rely on satellites for communication, navigation, and even missile detection. Without them, the world's defenses would be paralyzed. The economic cost of a solar superflare would be staggering. The National Academy of Sciences estimated that a severe solar storm could cause $2 trillion in damages in the first year alone. That's more than Hurricane Katrina and the 2008 financial crisis combined. Stock markets would crash. Banks would freeze assets because digital transactions would become impossible. Cryptocurrency? Useless. Even the simple act of buying groceries could turn into a dystopian barter system. And speaking of groceries, how do you buy food when cash registers and credit card readers don't work? Remember the good old days of landlines? Neither do most people under 30. A solar superflare would plunge us into an unthinkable silence. No cell towers, no Wi-Fi, no emails. Governments would struggle to issue emergency instructions. As if things couldn't get worse, the geopolitical implications would be disastrous. Nations with fragile power grids, already struggling under economic strain, would descend into chaos. Wealthier countries might hoard resources, sparking international tensions. Worse, rogue states or extremist groups could exploit the confusion to launch attacks. In a world without satellites or digital communication, retaliation would be slow and disorganized. Essentially, humanity would be fighting blind. While we're busy scrambling to rebuild from natural catastrophes, what if the next threat isn't from our own sun, but from somewhere far, far beyond it? Alien invasion. It begins like a strange light streaks across the night sky. At first, it's mistaken for a meteor, maybe a satellite burning up on re-entry. But as the light slows, changes trajectory, and hovers over a remote part of the Pacific Ocean, scientists around the globe realize this is no natural phenomenon. Then comes the static. Radio waves across multiple frequencies, incomprehensible but undeniably deliberate. It's not a question anymore. Humanity isn't alone, and whoever is out there has just arrived on our doorstep. What happens next could make every natural cosmic threat humanity has ever faced look trivial. Then, governments scramble to react as telescopes capture high-resolution images of the object hovering above Earth's surface. It's massive, metallic, and far beyond anything we've ever seen. Even our most advanced space agencies, NASA, ESA, and CNSA, can't make sense of its design. The first theories suggest it's an unmanned probe sent ahead to gather information. But why here? Why now? Despite centuries of dreaming about aliens, from H.G. Wells' War of the Worlds to modern sci-fi blockbusters, humanity's response to actual extraterrestrial visitors would be uncoordinated at best. Scientists would beg for caution and communication, while militaries would brace for the worst. Meanwhile, global panic spreads like wildfire, crashing the internet and triggering food shortages as survivalists stockpile supplies. As one commentator puts it, we thought we'd unite in the face of aliens. Turns out, we just argue faster. Now, let's address the elephant in the room, their technology. If an advanced alien civilization decides Earth is worth visiting, they're already light years ahead of us. Literally. Consider we're barely scratching the surface of interstellar travel. Our best spacecraft would take over 73,000 years to reach the nearest star, Proxima Centauri. Meanwhile, these visitors have crossed unfathomable distances to reach us, probably while streaming alien Netflix. Let's assume they're hostile. What weapons could they bring? Lasers capable of disintegrating cities, biological agents tailored to wipe out specific life forms, perhaps something we can't even conceptualize. And how would we fight back? With what? Missiles? Nukes? Those might work against other humans, but against a civilization with the power to traverse galaxies? It would be like throwing rocks at a tank. You might be wondering, why would aliens even bother with Earth? What could they want from us? The answers are unsettling. Perhaps Earth's resources, water, rare minerals, or even biological diversity, are rare in the universe. Maybe we're a prime location, a cosmic hotspot on some intergalactic map. Or worse, perhaps we're seen as an experiment gone rogue, and now it's time for the researchers to intervene. One particularly chilling theory suggests that any civilization advanced enough to reach us might view us the way we view ants. Interesting, perhaps, but ultimately expendable if we're in the way of their plans. Scientists have been warning about this for years. The search for extraterrestrial intelligence has detected unexplained radio signals from deep space, some of which seem too structured to be natural phenomena. We've sent our own signals into space, like the Arecibo message in 1974, essentially advertising our existence. The late physicist Stephen Hawking once said, "If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans." Yet, despite these warnings, humanity continues to beam signals into space, hoping for a friendly response. But what if the message that finally gets a reply is the cosmic equivalent of "come and get it"? Let's consider what an alien invasion might actually look like. Hollywood often depicts fleets of spacecraft firing lasers and deploying troops. But a truly advanced civilization wouldn't need to invade in such a crude way. Why risk a ground war when they could disable our satellites, disrupt global communications, or release engineered viruses that target human DNA? It could be as simple as them terraforming Earth to suit their needs, with no regard for us. Imagine waking up to find the sky has turned green and the air unbreathable. No giant spaceships blotting out the sun. Just quiet, efficient annihilation. If there's one thing humanity excels at, it's division. National borders, political rivalries, and economic disparities would make a unified response almost impossible. Even if aliens declared their intentions, you can bet some countries would try to negotiate, others would surrender, and a few might launch ill-advised attacks. History shows us how this would play out. Think of the Cold War. How close we came to nuclear annihilation simply because two nations couldn't trust each other. Now add extraterrestrials to the mix. As one scientist might put it, humanity's greatest weakness isn't a lack of technology, it's a lack of unity. So, what could we do? In the short term, not much. Our best bet would be diplomacy. But communicating with a species that evolved under entirely different conditions would be like trying to explain quantum physics to a goldfish. Even if we manage to establish a dialogue, there's no guarantee they'll see us as equals. Some experts suggest underground bunkers and contingency plans to preserve human knowledge, like a cosmic version of Noah's Ark. Others believe we should focus on advancing our technology, closing the gap between us and potential invaders. But let's be honest, that gap might as well be a chasm. And if you thought aliens were a tough opponent, wait until you hear about an unstoppable force from the far reaches of the cosmos already plotting humanity's end. Supernova explosion. To understand this threat, we first need to know what a supernova is. Think of a star, a massive ball of nuclear fire, burning brightly for millions or even billions of years. But eventually, like all things, it reaches the end of its life. If the star is big enough, its death is not a quiet fading away, but an apocalyptic explosion called a supernova. This is no ordinary explosion. The sheer magnitude of energy released is incomprehensible. In a matter of seconds, the star emits as much light and radiation as an entire galaxy containing billions of stars. For a brief moment, it becomes the universe's most brilliant spectacle, and its deadliest. Supernovae can happen in different ways, but the most infamous type for us involves a massive star collapsing under its own gravity after exhausting its nuclear fuel. This collapse triggers a violent rebound and an explosion so powerful it sends shockwaves racing across the cosmos. So, what does this mean for us? Earth is no stranger to cosmic disasters. We've survived asteroid impacts, solar flares, and even the odd gamma-ray burst. But a nearby supernova? That's a whole different level of danger. First, let's talk about proximity. For a supernova to really mess with us, it needs to happen within 50 light-years of Earth. That might sound far, but in cosmic terms it's practically our backyard. And guess what? There are a few candidates out there. Stars like Betelgeuse in the Orion constellation are ticking time bombs, ready to blow any time in the next few thousand years. When a supernova occurs close enough, it bathes our planet in a lethal dose of radiation. We're talking about high-energy gamma rays and X-rays that can rip through our atmosphere like a hot knife through butter. Our ozone layer, the thin shield protecting us from the sun's harmful ultraviolet rays, would be one of the first casualties. In a matter of weeks, our planet could lose up to half of its ozone layer. The result? Unfiltered ultraviolet radiation from the sun would flood the surface, frying ecosystems and making outdoor life impossible. It's not just a sunburn we'd have to worry about. Increased radiation could devastate crops, disrupt food chains, and cause mass extinctions. But the ozone layer's destruction is only part of the story. The gamma ray burst from a nearby supernova would directly irradiate the surface, potentially causing genetic mutations and widespread cancer in living organisms. And we might not even see it coming. Supernova radiation travels at the speed of light, meaning we'd have zero warning. By the time we detect it, the damage would already be done. And it's not just the radiation we need to fear. Supernovae also send out massive shock waves of particles called cosmic rays, which could batter our planet's magnetic field and atmosphere for years. Believe it or not, this isn't just science fiction. Evidence suggests that Earth has faced supernova-related events in the past. Researchers have found traces of iron-60, an isotope produced in supernova, embedded in deep-sea sediments and Antarctic ice. These isotopes date back millions of years, indicating that nearby supernovae have already blasted Earth with radiation. Did these events trigger mass extinctions? It's possible. Some scientists speculate that a supernova could have played a role in the Devonian extinction, wiping out 70% of marine species. So, if a nearby star went supernova tomorrow, could humanity survive? The short answer: probably not in the way we're used to living. Some underground bunkers could shield us from radiation, but rebuilding civilization would be a monumental challenge. Without a functioning ozone layer, agriculture would collapse, leading to global famine. The survivors would face a harsh, irradiated world where even stepping outside could be deadly. Thankfully, we're not entirely helpless. Astronomers are constantly monitoring nearby stars, especially those nearing the end of their life cycles. If a potential supernova candidate like Betelgeuse shows signs of imminent collapse, we might have time to prepare. But preparation is easier said than done. Here's another celestial event so powerful, it makes supernova explosions look like mere firecrackers. Collapse of the Earth's magnetic field. The Earth's magnetic field is a silent protector that has safeguarded life for billions of years. Generated by the swirling molten iron in the planet's outer core, it acts like a giant force field, deflecting charged particles from the sun and cosmic rays from deep space. Without it, the Earth would be bombarded by deadly radiation, and our atmosphere would slowly be stripped away. In other words, the magnetic field is not just a convenience, it's a necessity. But here's the thing: our magnetic field is weakening. Satellite measurements reveal that over the past 200 years, it has lost about 9% of its strength. This decline isn't uniform either. There's a particularly weak spot over South America and the southern Atlantic Ocean, ominously named the South Atlantic Anomaly. In this region, satellites experience malfunctions, and radiation levels are significantly higher. Scientists fear this could be a harbinger of something much worse. Earth's magnetic field isn't static. Throughout history, it has flipped, swapping the north and south poles. This phenomenon, called a geomagnetic reversal, happens irregularly every 200,000 to 300,000 years. The last reversal occurred about 780,000 years ago. That means we're overdue. During these flips, the magnetic field can weaken or even disappear entirely for thousands of years. If this were to happen today, the consequences would be catastrophic. Without the magnetic field's protection, the Earth would be exposed to intense solar and cosmic radiation. Solar flares and coronal mass ejections, massive bursts of charged particles from the Sun, would strike the planet's surface with full force. In 1859, a solar storm known as the Carrington event caused telegraph systems to spark and catch fire. If a similar storm occurred today, It could destroy satellites, disable power grids, and disrupt global communications. Now, imagine this happening with no magnetic field to soften the blow. Over time, the lack of a magnetic field would lead to something even more dire: the gradual erosion of Earth's atmosphere. Mars offers a chilling preview of what could happen. Billions of years ago, Mars had a magnetic field and a thick atmosphere. But when its core cooled and the magnetic field vanished, solar winds stripped the atmosphere away, leaving the planet a barren wasteland. Earth could follow a similar fate, with its lush, life-sustaining environment reduced to a desolate, irradiated husk. For humans and other life forms, the collapse of the magnetic field would be devastating. Increased radiation would drastically raise cancer rates and cause genetic mutations. Crop yields would plummet as ultraviolet radiation scorches the Earth's surface, threatening global food supplies. Even marine life wouldn't be spared. The radiation would penetrate the oceans, disrupting ecosystems from plankton to whales. Life as we know it would be on the brink. Our reliance on technology would make the situation even more dire. GPS systems, communication networks, and power grids would be rendered useless. Satellites would be fried by radiation, leaving us without weather forecasts, navigation, or global communication. Planes would be grounded, unable to navigate, and power outages would plunge cities into darkness. The global economy, already teetering on the edge due to climate change and geopolitical tensions, could collapse entirely. Civilization would be thrown back into the Dark Ages. To make matters worse, the magnetic field plays a role in regulating the Earth's climate. Scientists believe that changes in the magnetic field can influence weather patterns and ocean currents. A weakening or collapsing field could exacerbate climate change, triggering extreme weather events, rising sea levels, and widespread ecological disruption. It's a perfect storm of cosmic and terrestrial disasters. Here's the frustrating part: there's little we can do to prevent the collapse of the magnetic field. Scientists are monitoring the situation closely, using satellites and ground-based observatories to track changes. But predicting when or if a collapse might happen is incredibly challenging. Galactic collision. The Andromeda Galaxy is on a collision course with the Milky Way, and when they collide, the chaos will make Earth's surface unrecognizable, if we're still around to witness it. To understand the sheer scale of what's coming, you first need to grasp what's at stake. The Milky Way, our cozy galactic home, is a swirling disk of hundreds of billions of stars, planets, and gas clouds, all bound together by gravity. Andromeda, its cosmic neighbor, is even larger, with about 1 trillion stars. Right now, these two giants are speeding toward each other at an astonishing 110 kilometers per second. That's over 240,000 miles per hour, fast enough to circle Earth 10 times in a single minute. Their meeting won't be a gentle handshake. It will be a violent clash of titanic proportions. Galactic collisions aren't rare in the universe, but this one is personal because it involves us. Here's the first surprise. Stars within each galaxy won't slam into each other like a Hollywood explosion. Space is vast, and the distance between stars is enormous. However, the gravity of these galaxies will stretch and warp everything. Imagine 2 whirlpools of glittering water smashing together, each pulling the other apart as they merge. That's what will happen to the Milky Way and Andromeda. The collision will trigger shock waves of star formation as gas clouds compress under the enormous gravitational forces. New stars will ignite in bursts of light. like fireworks signaling the end of an era. At the same time, older stars, including our Sun, will be flung into new orbits, possibly ejected into intergalactic space, where they will drift in eternal darkness. And the black holes? Both galaxies have supermassive black holes at their centers, each millions of times the mass of the Sun. These cosmic monsters will spiral toward each other in a gravitational dance that ends in a spectacular merger. When they finally combine, they'll release as much energy as 1 billion supernova in the form of gravitational waves, ripples in space-time itself. Now, let's talk about the ground-level consequences, or lack thereof. By the time this collision peaks, about 4 to 5 billion years from now, our Sun will already be nearing the end of its life, expanding into a red giant and rendering Earth uninhabitable. But let's assume, for a moment, that humanity somehow survives. What would we experience? The night sky would be transformed into a chaotic swirl of stars, gas clouds, and debris. Astronomers today study the calm, predictable motions of celestial objects, but during the collision, those motions will be anything but calm. Earth's orbit could be altered, potentially sending our planet hurtling into the void, or crashing into another body. Worse yet, the violent turbulence could destabilize the Oort cloud, a distant region filled with icy comets surrounding our solar system. Millions of these icy missiles could rain down on the inner planets, bombarding Earth with impacts powerful enough to boil oceans and darken skies for millennia. Survival under such conditions? Unlikely. Why worry about something billions of years in the future, you might ask? Fair point. By the time Andromeda arrives, humanity might have colonized other star systems or gone extinct. Yet, there's a philosophical weight to this knowledge. Think of the galaxies we've studied, light years away, that already bear the scars of collisions. They serve as time machines, showing us our own future. The Milky Way's spiral arms, so familiar and comforting, will be stretched into chaotic ribbons, reshaping into an entirely new galaxy, likely an elliptical one astronomers have tentatively named Milkomeda. Meanwhile, there's a time bomb ticking in the heart of our solar system, and humanity is blissfully unaware of its deadly countdown. Expanding Sun. You've heard of climate change, supervolcanoes, or the next asteroid strike. But what if I told you there's a threat lurking that could make everything else on Earth look like a mere inconvenience? The very star that has facilitated life for billions of years is about to betray us in the most dramatic way possible. Now, let's rewind the cosmic clock. 5 billion years into the future. Earth's surface is a scorching inferno. The oceans have evaporated into the void, and the sky blazes with an ominous red hue. What brought us here? The Sun, our dependable nuclear engine, has burned through its fuel and entered its death throes, a transformation that spells doom for everything we once knew. But before we get into the doom and gloom, let's understand just what's going on here. The Sun, right now, is a middle-aged star. It's been shining for about 4.5 billion years, and it's halfway through its life cycle. But stars don't live forever. Eventually, they burn through their fuel, and when that happens, things get very interesting, especially if you happen to live on a planet near that star. In about 5 billion years, the Sun will exhaust the hydrogen in its core, the very fuel that powers it. This is where things start to get awkward. You see, when a star runs out of hydrogen, it stops producing energy in the same way. This causes the core to collapse under its own gravity, which heats it up even more. Meanwhile, the outer layers start expanding, and we're not talking about a slow, gentle puff. No, this is an explosive, violent expansion that will make your typical summer day look like a cool breeze. The Sun's transformation into a red giant will see it balloon outward to about 1,000 times its current size. Let that sink in. It's not just going to grow a little bit. The Sun will stretch out so far that it will swallow Mercury, Venus, and possibly Earth. In fact, Earth might be roasted alive well before that. The surface temperature will skyrocket as the Sun's heat intensifies, leaving nothing but scorched, barren land behind. This isn't just a bad day for Earth. This is game over for our planet. The oceans will evaporate into space, the atmosphere will burn away, and Earth will become a dead rock, if it survives at all. Humanity won't be able to do anything about it. By the time the Sun reaches this stage, we'll either be long gone or struggling to survive on an increasingly hostile planet. But let's not get ahead of ourselves. This cosmic nightmare is billions of years away. Right? Well, you're wrong. The thing about cosmic events is that they have a tendency to sneak up on you. Sure, 5 billion years seems like an eternity, but let's face it, human history is a blip on the cosmic timeline. And the truth is, the clock is already ticking. The Sun's slow expansion has already begun. So, what does this mean for humanity? Well, that depends on how we're doing in about 4.5 billion years. By then, Earth will likely be uninhabitable long before the Sun actually engulfs it. The expansion of the Sun will make our planet too hot to live on. It's already happening, albeit on a smaller scale. Our Sun's brightness has been increasing over the past few billion years, and Earth's temperature has been rising steadily as a result. That means that even in the short term, we're facing the effects of climate change, rising temperatures, and the slow loss of the habitability of our planet. So, the inevitable question arises, what do we do about it? Well, here's where things get a little tricky. By the time the Sun begins to turn into a red giant, it's possible that we won't even be on Earth anymore. We might have already abandoned it, launching ourselves into the stars in search of a new home. But let's be real for a second. The idea of packing up and moving out isn't as simple as it sounds. Sure, we've got some amazing technology, spaceships, satellites, and even the idea of terraforming other planets. But when the time comes, we'll be facing a problem of cosmic proportions. How do you pick up and leave the only planet humanity has ever known? And where do you even go? Let's assume humanity pulls off the impossible. We get to Alpha Centauri and find a planet that's capable of supporting human life. Even then, there's no guarantee it will be as easy as setting up shop. We'll face all kinds of challenges, from hostile alien environments to cosmic radiation. And let's not even talk about the likelihood of intergalactic politics. Space is vast and lonely. Perhaps the most disturbing fact of all is that humanity might not be around in 5 billion years to see the Sun's expansion at all. But if you look up at the sky after watching this video, you'll be staring at a star that will someday burn us all alive.